Okay, let me start the recording here. Just as usual, I'm projecting here that's the homework list, right? Okay, as I promised, that was through, that would be the homework list up to the time of the test. But we have coming up quickly here the 1.3 homeworks, or two, because this is an important section, so there are two homeworks from two sets of exercises from homework 1.3, but one of them, that was supposed to be due tonight, but I moved it back to Wednesday, okay? So, and we'll see about this one, but I moved this one back to Wednesday, but we want to work on that one, but a lot of people have started that one already. If you're finished with that one, then you can go on to part 2, and then, of course, if you finish both of these, then you can go ahead and take the quiz today after lecture while we have some time to get our questions answered. And I want to make sure everyone's got off to a good start on these assignments, okay, before I send you home. Especially that part 1. I'd like to have that one finished, right? So you can go on and work on the part 2. So I'm going to, I still have notes to give on these homeworks, though, so I'm going to talk first at you for a little while, okay? I know that's a little bit tedious, but I won't do it for that long, and then we'll have a chance to work on our solidify some of those things that I say, right? And in working on the homeworks. Now I mentioned the test, right? So don't forget the test is coming up, not this week, but next week, and as I told y'all showed you last time, right, the sample test is posted there, right, not the answers, but the sample test is posted. If you go, this is the Blackboard page, right, so there's the test 1 sample, so you want to print that and be working on that sort of concurrently with all those homework assignments that are due before the test, right, because this will really benefit you greatly for the test number 1 next Wednesday, right? The 25th. That's the first test. So don't neglect the sample test. And eventually, I will post the answers, but I want to give you a chance to work on this before you see the answers. So I'm not going to do that immediately. Not going to post those. And this is not something you're turning in, right? So you can seek help on this, right? You can get help in the Math Center or from one another. It's not an assignment. It's just meant to prepare you for the test, and it really is good preparation for the test. So don't neglect that. Now, it's kind of long, so that's why I have the test disclaimer there, right? So don't think that's the length of the test, okay? The sample is always longer than the test because I'm trying to just give you lots of practice before you come to take the test a week from Wednesday. Do y'all have questions about anything? Okay. Anyone? All right. Okay, I'm going to start. We'll work on that later. Okay. All right, so I'm going to launch here into the notes. All right, and so we can get through hopefully all of this or as much of this as possible. So you'll be ready for those homework assignments. So we've been talking about functions, right, and what functions are, and we saw one example of a function, this very straightforward example of computing the total cost, right, for a number of pounds of oranges, and that function, we express that function as a formula, okay, and that's a very common way that functions are represented in practice. Very common, right? Functions are often expressed as formulas, okay? But that's not the only way that functions are represented. They're represented in other ways as well, and these other representations have advantages, so that's why we represent functions in different ways, okay? So we'll frequently be working with functions expressed as formulas because there are good things about having functions expressed as formulas, but we'll also be working with functions expressed other ways as well. So I want to show you another example here of a function that's not expressed as a formula, not represented as a formula, okay? But it is a function because it's a rule that we use to take some quantity that we know, right, okay, and then, or we can easily measure, and then we use that to predict the value of a quantity that is not so easy to measure or that we want to know for some reason, okay? All right, so here's a table that that advisors in college sometimes refer to, okay, when they're advising students. And what this table shows is, well, you can see it here, right? In the first column, there's the number of hours that a student, I'm sorry, in the first row, there's the number of hours that a student is working. And then in the second row there, these matching values are the number of credit hours that a maximum number of credit hours, I should say, that the student is recommended to enroll for, right? Okay. So if a student, for instance, is working, not working, right, working 0 hours, then the maximum is usually 16. Okay, that's the maximum recommended number of credit hours. But on the other hand, if you have someone who's working full-time, right, 40 hours a week, then that maximum recommended number of credit hours, right, that drops dramatically, right, okay, to just 4 hours, all right? So this table, right, provides a method, right, that the advisor can refer to quickly, right, and give a recommendation to the student for how many hours they should be enrolling in, right? Okay, so this is a function, all right, and if that's not clear, then we'll make it clear just when we talk about the function. I've given the function a name, by the way, okay? I've given the function a name here, g. I don't know why g. That's just a popular name for functions. It's not really a very useful name for this function because it doesn't tell me anything about how this function is working, right, okay, or what this function is doing, but nevertheless, that's the name that I gave it here. So what is the input in this particular function? What's the value that we know, right, okay, in this situation? Yeah, you know the hours worked, right? So if you come into your advisor and you're trying to get advised, right, on how many hours you should take in your schedule, right, that you're going to know, right? Oh, yeah, this is how many hours I'm working, right, okay? So that's the number that is known. I won't say it's easy to measure, but that's the number that's known there, right, okay? So it's the number of hours worked. All right, so let's give that just for reference, right? Okay, let's give that a quantity a name, right? A variable name, and so we can really pick any variable name that we like, right? But our favorite variable for the input quantity is what did we mention last week? What? X, right? Yeah. Okay. Emiliano, right? Okay. Yeah, I gotta speak up so I can hear you. You know, I'm a lot older than y'all are, right? So I can't always hear things, all right? Yeah, so so typically in mathematics, right, when we're working with a function, once we've identified the input quantity, right, we'll choose a variable to represent that, right? And remember, that's called the input variable. What's the output from this particular function that I was calling g, right? So what's the number that we want to determine in this situation? What now? The credit hours, right. Actually, it's the maximum number of credit hours, right? So that's what we're trying to find, right, by using this function. So that's the output quantity, right? Let's also give that a name. And our favorite name, as we mentioned last week, for output quantity is y, right? And so that would be called the output variable, right? That's the letter that you use to represent the output quantity. But again, what you choose for the input variable and what you choose for the output variable, it doesn't have to be x and y, right? Okay, these are just kind of default choices, but you can choose other letters, right? Depending on the situation, some other variables might be more convenient. So in this case, what is the function rule? So this is not a formula, right? Okay. What's the function rule that the advisor uses to match the input quantity with the output quantity? So what's the mechanism here, or the method, right, that the advisor uses to take the number of hours worked, right, X, and match that to Y, right, the maximum number of credit hours? What is that thing? There it is right there, right? Okay. So what would you call that? Well, yeah, y equals f of x is important notation, okay? But I'm asking a very simple question here, so I think you're stumped by its simplicity, all right? Okay. When I say what is this rule, what system, right, are we using to take the input there and match it to the output? What do we have here? This is not a formula, right? Okay. So what would you call this thing that's drawn there? A table, right? Okay, yeah, that's right. So in this case, we're using a table, right, to match inputs and outputs, right? So we're not using a formula. We're not plugging this input number, right, into a formula and computing the matching output, right? We're just looking at this table, right? Okay. In the table, we have the inputs, and there are the matching outputs, and then we're just reading the table, all right? So tables are another really useful way of expressing functions, okay? They have drawbacks, too, okay? They have drawbacks, too. We'll talk about those in just a second, right? But that's a second way that we often see functions expressed in practice. Actually, it's quite common in practice, although we don't see it that much in math classes. In real practice, it's actually quite common to have functions expressed as like this, as tables, okay? All right, and all right, so that is our a function rule in this case is a table. Whenever we express functions as tables, the book says that such a function is expressed numerically. Okay, so when the book says write down a function numerically, they mean write it down as a table. Okay, I always say table, but that's the term that the book uses. All right, so I've given that function a name. Remember, the name is g, right? Okay, so, oh, by the way, we didn't convince ourselves yet, but it's pretty obvious, but we didn't convince ourselves yet that this really is a function, right? To make this a function, we have to have for each input, how many matching outputs? Yeah, just one, right, okay? So that's clearly the case, right? In this table, for each input, you have just one matching output, right? See, the advisor or the student, right, doesn't want to be in the situation that they go to the advisor and the advisor and tells the advisor, oh, I work 20 hours. You know, they don't want the advisor saying, well, you know, you could take 10 hours or you could take 15 hours, right? Okay. You know, we don't want that sort of fuzziness there, right? Okay. But that's not in this table, right? We have the advisor's going to give a clear answer. Oh, you're working 20 hours. You should take a maximum of 10 credit hours, right? So each input here, right, gives results in exactly one recommendation from the advisor, right? One matching output there, right? So definitely a function. And since we know it's a function, then we can use function notation, right, that we talked about last time with such a function, correct? Okay, so here I'm using function notation to express this value. How do you read that off the page? Not what does it mean or what is its value. We'll get to that. But how do you just read that expression? So if I said, read that for me aloud, what would you say there? You would say, interpret, and then what would you say when you got to this? What? The G of 30, right? Yeah, that's how you read that, okay, off of the page. Remember, that doesn't mean G times 30, right? Okay, that's something different. This is how you read it, is G of 30, all right? Okay, now let's get to the interpret part. So what does G of 30 really mean, okay? So remember, well, you may not remember, but you're going to recall now, right? Last time I said, when I tell you to interpret function notation, that means just explain what that notation means, right? It does not mean attach a value to it. That is the evaluate instruction, okay? So in words, what does that quantity G of 30 mean? Okay, so in words, what are we trying to say when we write down G of 30? So what is the purpose of that notation? What does that notation mean to us? Okay. By the way, now we're going to have lots of questions like this in your homework, and those are going to be multiple choice questions in the homework, so that makes them kind of easy, all right? But on the test, they will not be multiple choice. You will have to actually write out a sentence. Remember, interpret means write down in words, okay? So in words, what does G of 30 mean? Now, don't try to make it complicated, okay? It's not a deep thought, all right? So I know you're thinking in a math class this has to be complicated, and some things in math class are complicated, but this is not one of them, all right? So this is really a pretty simple idea to write down. Yeah, what is G of 30? What am I trying to capture with that notation, right? G of 30. How does this function work? What does this function do for us, right? Yeah. It is telling us number of hours worked. Eduardo, where is the number of hours worked in that expression, obviously? That's X, right, okay. So you're trying to say, oh, this expression means the student is working 30 hours? That is a part of the expression, okay, but that's not the entire expression, all right? If I just wanted to say the student is working 30 hours, I would say something, in mathematically, if I wanted to say that, I would say something like X equal 30, okay, right? Because X means the number of hours worked, right? So if I wanted to say the number of hours worked is 30, I would say X equals 30, all right? But G of 30 has more information in it than just the number of hours worked, although that's part of it, okay? So can you elaborate a little bit, Eduardo, on your interpretation of G of 30? So it does involve number of hours worked, but it captures something else. What else does it capture? Because remember, this is the function, right? Okay, so remember the function does something with that number of hours worked. What does it do with that? Yeah, Uni. The max number of credit hours. Okay, so you've got an important part of that, the maximum number of credit hours, right? Okay, but you do have to take into account what Eduardo said, right? Because G of 30 has the number 30 in it, right? Okay, so can you put those two things together for me now? You said it's the maximum number of credit hours.
The number of hours worked.
Okay. Well, I say that.
The number of hours worked equals the maximum number of credit hours.
Number of hours worked equals the maximum number of credit hours. You know, I don't think the.
What are you telling me to say?
Huh?
What are you telling me to say?
Yeah. No. What I was telling you is. When you said somehow G of 30 involves maximum number of credit hours, you are right, okay? But the 30 is part of that expression, right? Okay? So you have to work that into your explanation, into your interpretation, all right? So how can you get you said the maximum number of credit hours, but you've got to work the 30 in, right? Okay? And so that's what I was telling you. Listen to what Eduardo said. Eduardo said the 30 means what? Number of hours worked, right? So, Uni, can you put both things together for me? What you said and also what Eduardo said. Because that's going to be the correct interpretation.
The maximum number of hours worked is 30?
No, okay. No, it is maximum something, but it's not maximum number of hours worked, okay? Yeah, okay. You don't have to give me the value from the table. Yeah, go ahead.
The number of hours worked of 7 credit hours.
Okay, so you remember from the table that somehow 30 was related to 7. Okay, that's going to come up when we're evaluating G of 30. Okay, but in the interpretation, you don't need to know the 7 yet. Okay, so you don't need to know the 7. All right, boy, y'all are hitting just all around it, but not quite piecing it together right, okay, in quite a clear way, all right? Anybody else want to make a stab at it? Don't be shy, okay? You're going to have to experiment a little bit with these things on your homework anyway, okay, so that you can be ready for the test, right? Okay, so there's no harm there in making a suggestion, all right, about what you think the right phrase is here, okay? All right, well, all right, so let me put it together for you, okay? Once you see it, then it will be very easy, okay? It will be very obvious. It means, G of 30 means the maximum number of credit hours when a student works 30 hours. You see, right? You have to put those two ideas. Was that in your head? But you just have to say it, okay? Right, okay. Yeah, well, that's what I was looking for, all right? So this is our interpretation of G of 30. This is what it means, okay? The maximum number of credit hours, because that is the output, right? The maximum number of credit hours, that's what y'all told me. And then the 30 comes in here. You have to work that into your interpretation. When a student or when the student works 30 hours. See, that's really pretty easy, right? Okay. You can't just say the student is working 30 hours. That's just the 30. But when you, but G of 30 means the whole thing, the maximum number of maximum number of credit hours when a student works 30 hours. Those interpretations now are really important. The reason they're important is when you're using function notation or when you're reading function notation, you've got to be able to understand what the notation is telling you, okay? Right? That's super important. Mathematics without meaning is not going to be very useful to us, all right? Now, what about evaluating G of 30? Okay, that's where you actually, Leslie, that's where you're going to attach a value to this expression, all right? So that means what is the value of G of 30? In other words, what is the maximum number of credit hours when a student works 30 hours? You already told me it's what? 7. That is what you read from the table, right? Okay, that is what you can read from the table. So we can, now I can actually use an equal mark. G of 30 equals 7, all right? That's what the table told us, right? G of 30 is 7. So see there, with evaluate, we're attaching a value to this expression, okay? Not explaining what it means. See, I can write down G of 30 equals 7 without having any understanding what that equation is telling me, right? Okay? That's why the interpretation is really important. When I write down an equation like this, I want to make sure I understand what that equation means to me, right? Okay? In practice, what is that equation really telling me? Oh, by the way, I didn't mention this earlier, but I want to remind you of this. If I write down just y equals g of x, what does that tell me? See here, I'm not filling in a value for y, I'm not filling in a value for x, I'm just writing down y equals g of x. What can I deduce from that equation? That means y is a function of x, okay? When you use the function notation with these two variables, what you're saying is this quantity is a function of this one. In other words, I have some rule or method, right, that I can use to take this quantity and determine the quantity y, all right? And of course, that rule or method in this situation is a table. Let's see, let's read this question because we often have to use functions backwards. Frequently, with functions, we'll be given the output value and we want to find the matching input, okay? So that's this question. Find x such that g of x is equal to 16. That looks like solving an equation, right? That's really what we're doing, okay? But notice here, we're given the output, we're asked to find the matching input. That's easy, right? You're just going to read the table again, but you're going to read it backwards. So do we have such an x? Let's look back. We have to look up and see that, right? Okay. So we have to refer to our table. What is it? 0. Okay, so the solution to this equation is x equals 0. Okay, that's the input, right? That gives us a matching output of 16. Well, this question is easy, right? What does x mean? That just means the student is not working it, right? Okay, so here's a student that is coming to school without working, all right? Finally, I have kind of a thought question for you here, but we're going to kind of answer it very rigorously, all right? This last question says evaluate g of 25, okay? Evaluate g of 25. All right, so that should be easy, right? Because we just have an input of 25, right? So we're just going to go to the table and find what's the matching output for the input 25, right? So that should be an easy question to answer. The problem is, of course, when we go back to the table, and look at the table, notice in that table we don't have an input of 25, okay? So, you might want to guess there and say, oh, well, if the student's working 25 hours, we should recommend somewhere between 10 and 7 credit hours, right? Okay, and that's a reasonable answer in practice, but in this class we're going to be very strict about this. We're going to say g of 25 does not exist, or g of 25 is undefined, okay? We're going to treat the functions really rigorously, and because I don't have 25 listed as an input there, I'm just going to say g of 25 is undefined, all right? So I'm going to give a very strict answer to that question, okay? Because this is a math class, okay? So, and the strict mathematical answer would be, can't use an input of 25 because 25 is not an input for this particular function, all right, the way it's written. 25 is not in the, what's the set of all inputs called? The set of, when you have a function and you list out all the possible inputs, what's that set called? Begins with a D. Domain, right, okay. So since 25 is not strictly in my domain here, the way this function was written, then I would say g of 25 is undefined, okay. I can't say equal undefined because undefined is not really a number, so I'm going to put an arrow there instead. G of 5, that's undefined, okay? And the reason that's undefined is because 25 is not in the domain of that function. Now, maybe it should be, okay? And maybe we can rewrite the table so that it is, but for the time being, it's not, okay? So I'm not going to allow it as an input for this function. You, in your homework, it may ask you if you have a situation like this where you're trying to find an output for an input that's not in the domain. The instructions in the homework may say type in, they may say type in undefined, or it may say type in D and E for does not exist. They'll give you some sort of instructions for how to indicate this particular situation. All right, so let's see now. So now we've seen a function represented by a formula, so that's very common. Here we've seen a numerical function. That's a function represented by a table. Okay, now we're going to look at our really third important way of representing functions, and that's through graphs. Okay, so we often represent functions through graphs of sets of points. Here's kind of an elaborate graph, actually. All right, so what this graph shows is the, let's see, what does it show? The average hourly wage for young college graduates, I guess sort of your age when you graduate, maybe in the early 20s, right? So that's the average hourly wage, and I forgot what the input here is, but I think that's elapsed years from sometime. Oh, from 1900, okay? So, well, we don't go back early in the 20th century there. It just starts at, notice there, the the graph there starts at 90, okay? So that would correspond to year 1990, right? Okay. So in that year, there was the average hourly wage. And notice it's fluctuated somewhat, right? Okay. So it dropped here in the mid 90s. I don't exactly know why in the mid 90s it dropped, but and then it started climbing in the late 90s. That was during the first internet boom, okay? So maybe that was around the time y'all were born. So first internet boom, and then peaked out there, and then had another dip. This is corresponds to the Great Recession of about 10 years ago. And then lately it's been climbing again. So this is a good time for you to become a college graduate, all right, because average hourly wages for college graduate have been going up, all right, in recent years, okay? So that's good news for you, all right? All right, so pretty clearly here in this situation, what is our input? What's the number that we're going to start with here for this particular function? Kevin, what's our input? So remember the function, you have an input, that's the number that you start with, right? And then you use that to determine some value, okay? So in this situation, most likely where would we be starting here? What would we've got two quantities, obviously, right? This average hourly wage and this elapsed year. So normally when you read a graph like this, what would you start with first? You're going to start with the hourly wage and then predict the year, okay? I think most likely we would do that the other way, all right, okay? We would take a year, right, okay, and then we would use the graph, right, to determine, oh, what was the average hourly wage in that year, okay, right, okay? So, hi, Crystal. Yeah, all right. So normally when we express functions as graphs, the input quantity will be plotted along the horizontal axis, the x-axis. So you can almost always determine the input quantity from what quantity is plotted along the x-axis. Okay, so input here is going to be elapsed years. All right, from 1900. All right. So again, let's give that a name there. Okay. So I'll use X again, kind of stuck on that one. So this is elapsed years from 1900. And obviously, what's the output then? Because we only have one other quantity here, right? So Kevin, what's the output? That's right. It's the average hourly wage, right? So I'm going to call that value y. And in this situation, obviously, what is our function rule? So what's the method that we're using to take the elapsed year, right, and match that to the average hourly wage, okay? I mean, what system are we using to do that? Is Evelyn here? I'm trying to get through my whole list of names. I'm almost through, so I can start again and start picking on y'all. All right, Evelyn not here. Salma, is Salma here? Salma, okay. Let me ask you this question then. What is our function rule? All right. So what's the mechanism or what's the system or method, any word that means that, right, that we use to start with the elapsed year, right, okay, and then determine the average hourly wage for that year? I mean, what's the way that we do that here in this situation? You want me to scroll back up? So if I give you an elapsed year, say, say 20, which would be 2010, because that's 20 years after 1990, okay? So if I give you that year and then say, okay, what was the average hourly wage in that year? How do you do that? What method do you use to figure that out for me? But how would you find that hourly wage in this picture, how would you do that? Huh? Yeah, by using the graph. That's right, okay, by using the graph. How would you, in fact, use the graph to do that, Salma? So the year is 2010, 20 elapsed years, okay? So how would you actually use the graph to find that hourly wage? Just tell me what to do. If I was a grade schooler, just tell me what I would do to find that average hourly wage. You're right, you're going to use the graph, right? So what do you do? Oh, I'm sorry. It was from not 1990, but I told you wrong. Okay, elapsed year 110. That's 2010. I keep thinking we're counting from 1990, but we're counting from year 1900. All right, so let me start again. In elapsed year 110, which is 2010 still, how would you find the average hourly wage? You go to 110, right? And then what? You go up, right? Until what? Forever, or where do you stop there? Huh? This dot right here, where you hit the graph, right? Okay? Where you hit the graph, and then what? You just look to the left, right, and see what value that matches, right? Okay? Exactly right. Okay? So you to answer this question, you use the graph. So your function rule here is the graph. Okay? Yeah, it's the graph. That's the system that you use to take the input quantity and find the matching output quantity. Let's see what that is if we can read that very well. So come across here, and that looks like, let's see, that's 1850. So about 1825 maybe, right? Okay, 1825 is the matching output for input of 110. Okay, yeah, all right. So perfect, yeah. The function rule there is the graph, and this is our other popular way now of expressing functions, okay, is through graphs, okay? So we've seen three: formulas, tables, and graphs. That will be, for this course, almost all functions will be expressed as formulas, tables, or graphs. Now, when you get into later courses, you're going to learn about functions that are created in a little bit more exotic fashions, okay, than tables, formulas, and graphs, okay? And so sometimes you can have a little bit more complicated methods for defining and creating functions. But even with those more complicated methods, you're going to want to usually immediately convert them to a table, a formula, or a graph. Okay, right? Because those are the familiar ones, and those are the ones people know how to use really well. Okay. All right. So a graph there. Let's see if we can interpret and evaluate h of 90. Interpret and evaluate h of 90. Right. So what's our interpretation for h of 90? What does that mean to us? Not what is its value. We'll figure that out in a minute, right? But what does that notation mean? Okay, so just think back to the original, to this previous example, right? H of 90 means what? Yeah, what year was that, by the way? So this is elapsed years from 1900, so 90 would be what? What? 1990, right? Yeah, that's it. See, Kevin, you got it already, right? Okay, that's the interpretation, right? Okay, it's the output, right? Which was the average hourly wage, right? Corresponding to the input 90. That means in elapsed year 90 or in 1990. And now that's the interpretation. Now to evaluate that means we have to actually say what that average hourly wage was, right? And that's where the graph now is useful, right? So we can read that one off pretty easily, right? Okay, it's going to be right there, correct? You'll see where I'm pointing. It's going to be right there. Oops, I wrote on that one. I didn't mean to. It's going to be right there, right? Which looks like what? Let's see. This is 1750. So that's about 1775, okay, approximately. So the evaluation here is 1775. Actually now, just through that simple evaluation, you can start to get a feel now for kind of what the advantages to graphs are, and what their disadvantages are, and also kind of what the advantages to tables are, and what their disadvantages are, and kind of what the advantages to formulas are, and what the disadvantages are, okay? And that's why we often have to rework functions in different representations. So sometimes we'll have a function expressed as a formula, and we want to rewrite it as we want to recreate it as a graph, okay? Or sometimes vice versa, we'll have a function expressed as a graph, and we want to recreate it as a formula, okay? Because there are advantages to writing down function rules in these different methods, okay? Here's one of the disadvantages to graphs, okay? When I said h of 90 was 1775, that was just kind of an estimate on my part, right? Okay? I was just reading the graph, and I said, oh, that point looks like it's 1775, okay? But I wasn't being necessarily precise there, okay? So that's one of the disadvantages to using a graph. It's hard to be precise when you're using graphs, okay? It's hard to find the exact output that matches a given input, all right? So precision is sometimes an issue with graphs. But the nice thing about the graph is it was really easy to read that value off, right? Okay, I just looked and it was really easy to make that evaluation. It just wasn't very precise, okay? What method of representing functions other than graphs is going to be more precise? So will allow you to determine an output much more precisely for a given input. So, what now? Table, right, yeah. Sky, a table is going to be perfectly precise, right, okay? If you can find the input in the table, you'll know exactly what the matching output has to be, right, okay? That's also very easy to use a table, right, okay? You don't have to do any computations at all, okay? You don't have to do any computations, you just look at the table. We didn't have to do any computations with the graph either, okay? Avoiding computations is sometimes very good because, you know, people are prone to making arithmetic mistakes, right? Okay, so in practice, frequently functions are expressed as tables in practice because they help avoid arithmetic mistakes. All right. Okay. Now, but a formula also can be very precise, right? Okay. With a formula, you can do calculations with a lot of precision. All right. So you can also be precise with formulas, but you really can't so easily with graphs. All right. Now, what are some disadvantages, though, to, for instance, a formula? I just mentioned it. With a formula, you're going to have to do what? What? You're going to have to do arithmetic. That's right. Okay, yeah. With a formula, you're going to have to do some arithmetic. You're given an input. You're going to have to plug it into the formula. You're going to have to do some arithmetic, and that is prone to mistakes, okay? So formulas can lead to mistakes, all right? They're very precise, but they can lead to mistakes. Now, with table, you really can't make a mistake unless you just read the table wrong, okay? Because there's no arithmetic involved. But the bad thing about tables is the domain is usually very small, right? Okay, you have to, in a table, you have to list all the input values separately, and you just can't list that many values, okay? Otherwise, you're going to come up with this super huge table, okay? And that can be clumsy and difficult to use. So tables have disadvantages as well. All right, let me show you a really great advantage to graphs, though, okay? With graphs, you can answer this kind of question usually very quickly. That's the next question I have on my list here. What was the maximum hourly wage and when did that happen? Okay. That's a tough question to answer from a formula. Okay. That's not going to be an easy question to answer if you had this function expressed as a formula. but it's pretty easy from the graph. Because what are you going to look for on the graph? So let's answer that question from the graph. What was it there? What was the maximum hourly wage, and when did that happen? Where is that in the picture? Yeah, I can tell y'all are reading it because you're whispering to yourselves, okay, but you got to tell me. So where is that maximum hourly wage in that picture? 2018, yeah, good for you, right? It's 2018, right? That's what I was saying, right? Okay? Don't look here, okay? All right? It wasn't there. It's actually over here, right? Okay? So, see, you can see that very quickly from the graph. Oh, yeah, the maximum hourly wage, that happened in 2018. Yay, okay? And what was it? It looks like it's about 2050, right? Okay. Again, you can't. That's a problem with issue with graphs, right? They're hard to read accurately, but at least we can get an estimate there. It looks like it's about 2050, and that occurred in elapsed year 118, right? Which is 2018. So that's a question that you can answer very quickly from a graph. That would be a hard question to answer from a formula. Okay. That's a hard question to answer from a formula because, well, just because the way formulas work, right? Okay, but from a graph, a very easy question to answer. So that's advantage to graphs. Okay, we can sometimes answer difficult questions quickly by looking at a graph. Okay, and in fact, we're going to exploit graphs for that purpose throughout the semester. Okay, we'll be able to answer some really tough questions, or at least get estimates for answers to some really tough questions from looking at graphs. Okay, that we cannot get from formulas or other means. All right. Okay. I got one more question here, though, because this is our next big topic. What is the domain of this function? Okay, and what is the range? So looking at that function, by the way, I called that h. That's the name I gave to this function. So what is the domain of h? So what numbers can we use as inputs for this particular function? The way the function is created, what numbers can we use as inputs? Could I use 50 as an input, for instance? No. Okay, right. I could use 50, right? Okay. Or could I use 150 as an input? No, right. Okay, so I'm restricted to what my inputs can be, right? So what numbers can you use as inputs? To 90 to what? Yeah, 90 to 118, right? Okay, yeah, because those are the only numbers that are plotted there, right, on the x-axis, right? Okay, so the domain of this function is just numbers between 90 and 100. We can write that set down, by the way. There's a variety of ways of writing down that set of that domain, but one way is just using an inequality. So you can say x, right? That was the input, has to be between 90, bigger than or equal to 90, and has to be less than or equal to 118. Okay, so there's a way of expressing the domain of h. What about the range now? So remember, the range is the set of possible outputs. So what outputs, what y values can we get from this graph? Yeah, we just look down here and see what the smallest one is. Okay, it's not 15. All right, Leslie. All right. Yeah, okay. That's how the graph is drawn. But, that's how the axes are drawn, right? But the graph doesn't dip down all the way to 15, right? Okay, so the smallest output is like right there, correct? Can we estimate that what that is? It's almost 1650, right? So I would say maybe 1640 as the smallest, okay? Again, see, it's hard to be precise when you're reading graphs. That's one of the bad things about graphs, right? So maybe 1640, and what's the highest output? Y'all just told me a moment ago there. Up here, right? Okay, which was about 2050, right? Okay, approximately. So you see the range there, the set of y values, right, for this function ranges between, again, this is our estimate from looking at the graph, between 1640 and 2050, okay? Those are the only outputs we can get from this particular, the only outputs that we can get from this particular function. That range, that was pretty easy to determine from looking at the graph. At least we got a good estimate from looking at the graph. That sometimes is a hard thing to figure out, though, if you have a function expressed as a formula, what the range is, and also a little bit hard to figure out sometimes from a formula what the domain is, but for a function. But you can tell that very easily from a graph. So there's another great advantage to graphs, okay? It makes it sometimes easy to determine what the domain and range of the function is. And often we're interested in knowing that. What's the domain and range of a particular function? But the bad thing about the graph is can't really be precise there, okay? We get a good estimate, but sometimes surprisingly good, but not certain that it's exactly correct. Okay, all right. So formulas, tables, graphs. Those are the three major ways that we're going to use to represent functions. Sometimes the book says verbal representation of a function. That's where you sort of describe how a function works in words. I'm less keen about that, but it is going to appear in your homework occasionally, okay, to describe a function rule in words. I don't think we usually do that in practice very often, but it is it is described in the homework. Okay, now we were discussing there in that last question the problem of determining the domain and range for a function. And so we need to practice this a little bit, okay? Because this is an important skill. So we're going to do that now. We're going to look at some examples of some functions, and we're going to try to see if we can figure out what the domain is as best we can, and possibly what the range is. But the range is much harder to determine, okay, than the domain. So the domain we'll usually be able to figure out pretty well for a function. There are some exceptions to that, but range is often trickier, okay? And so we're not going to do as well with determining what the range of a function is as we will the domain, okay? All right, so let's start with some function represented by formulas. Okay, so there's a pretty simple function formula, x squared minus x, right? So your input there is x, the matching output there is y, and the name of this function is g, okay? Let's try evaluating this function for some simple inputs. So this is just really arithmetic, but sometimes algebra, so, but it's fairly straightforward. So let's see, g of 4, well, that's going to be 4 squared minus 4, right? You're just going to substitute the 4, right, where you have your input variable in your formula. Well, nothing to that, right? That works out to be 12. That's 16 minus 4, which is 12. Well, by the way, our little review of our order of operations that we did at the beginning of the course here really comes in handy when we're evaluating a function notation, right? So now, by the way, I'm not interpreting here, right? Okay, I'm just evaluating, so I'm just telling you what the value of g of 4 is, okay? Well, this one should be equally easy, right? g of minus 4, except sometimes you're going to make a mistake there, all right? Here's what you're going to want to write down sometimes, and that's not correct, all right? Because if you write it like this, your answer is going to turn out to be something like negative 12, okay? Because when you square 4, that gives you 16, right? And then there's minus 16, and then minus a minus 4 is plus 4. So you're thinking, okay, this is minus 16 plus 4, which is negative 12. That is wrong. What did I do wrong there, though, in evaluating g of minus 4? So what mistake did I make? Why is the matching output not minus 12? Yeah, it's a sign mistake, right? What sign mistake did I make there, Juliana? Yeah, what about the negative 4? Obviously, it's got to be the negative 4, right? Because that's the input. But what did I do wrong with minus 4? Yeah, why should that not be minus 16? What should be outside the parentheses?
Wait, it's supposed to be positive.
It is supposed to be positive. Yeah, you're right. Why is it supposed to be positive, though? What did I do wrong there?
You made negative 4. Like, I don't know how to explain it. But like, it's supposed to be positive because the two negatives were gonna cancel out.
Well, yeah, so look, what your function formula says here is you're taking your input and you're squaring it, right? Okay? So that means I am supposed to square the entire quantity minus 4, all right? I didn't write it like that, though. What I did was I just squared the 4, but I didn't square the minus sign, okay, right? So I ended up with minus 16, all right? So when I actually input that, when I actually plug that minus 4 into the formula, I have to do that very carefully, okay? Otherwise, I'm going to end up with a sign mistake. So I should have squared the entire quantity minus 4, all right? Not just the 4, but the entire quantity minus 4, right? Because I'm plugging all of that quantity minus 4 in for x, all right? Now, this, however, was correct, all right? You're subtracting a minus 4, so I wrote that down properly. Let me give you a little rule of thumb here. When you're plugging negative quantities into expressions, see, I was plugging minus 4 here in for x in this expression, you should practice safe math, and you should put that negative quantity in parentheses, okay? Put that minus quantity in parentheses. Otherwise, you're likely to end up with a sign mistake like the one that I just demonstrated, okay? Now, you may think that you're not going to make that mistake, but that mistake is very easy to make, all right? So avoid that by when you're plugging negative quantities into expressions, surround them in parentheses, okay? You really don't have to do this with positive quantities, but with negative quantities, you really should, all right? So let's see, what is the correct value here? It's actually a little bit bigger, right? So I have negative 4 squared, which is how much? Positive 16, right? And then plus 4 is 20, right? So the actual output there is positive 20. All right, now let's do a little bit of algebra. So now I want to try g of a plus 1. Okay, g of a plus 1. So we're actually going to evaluate this function at a symbolic input, all right? At a symbolic input, a plus 1. But you do it exactly the same way, okay? You're going to take the a plus 1 and you're going to substitute that wherever you see x in the formula. So don't be confused here that you have a variable in your input. You have a variable in the input, and you also, of course, have your variable in your formula. you still do the evaluation exactly the same way, all right? So you're going to have a plus 1 squared and then plus a plus 1. Now you just have to simplify this properly. Y'all are good at simplifying this properly, though, okay? How do you simplify a plus 1 squared? It's not a squared plus 1 squared, right? How do you do this? So we practice this, right? Yeah, Taylor. What now? Oh, minus there? That's also a good mistake, okay? Because that's a mistake I will see from students as well, all right? Frequently just miscopying the formula, okay? It's hard to know how to fix that mistake other than just double check your work, okay? All right, so how do we square a plus 1? It's not a squared plus 1 squared. If you want to square a plus 1, what are you going to have to do? You have to do it the hard way, so what do you have to do there? What now? That's right. Emiliano, it's a plus 1 times a plus 1. Stay awake, Emiliano. This is going to be on your homework, right? Huh? Yeah, right. Okay, yeah, I believe that. All right. So a plus 1 times a plus 1, right? Okay. Now, the minus a plus 1 is a little bit easier, okay? You're just going to distribute the minus sign. So you get minus a and minus 1, okay? Just minus times a and minus times 1 is minus 1. All right, now let's multiply out the a plus 1 times the a plus 1. So what does that give me? A times a is a squared plus 2a plus 1, right? Minus a minus 1, okay? And now just add your like terms. Do we have any like terms there to add together? Yes, right. 2a minus a is a like term, right? So you get how many a's there? A, right? And then plus 1 minus 1, cancel out. So we just get a squared plus a. That's it. That's going to be your result. All right, I'm going to skip this one, but it's the same idea. You're going to substitute x minus h into your formula wherever you see x. Do not get confused by the fact that you have x here and also x in the formula. Wherever you see x in the formula, you're going to substitute the entire quantity x minus h, all right? So you'll end up with, I'm not going to simplify it, but you'll end up with x minus h squared, right? X minus h squared, and you know how to square that now, minus x minus h. And then just simplify that. All right, so let's finish with the question I was really getting at here, okay? Although it is important to be able to evaluate inputs for functions, the question I'm really interested in is, what is the domain of this function? So here we have a function given to us as a formula, and we want to know what numbers can I use as input to this function. So we don't really have any other information about the function other than this formula, okay? Here's how you can answer that question, all right? You're going to assume that the domain is as large as it possibly can be, okay? And by as large as possible, as it possibly can be, I mean, what numbers can you plug into this formula and actually carry out the arithmetic? Never mind if you need a calculator to help you or not. That's not the problem, all right? But what numbers could you plug into that formula and actually do, if you have a calculator, if you need it, the arithmetic in that formula? What is the arithmetic in that formula, Ben? It's not very complicated arithmetic. What's in there in that formula? What are we doing in this formula? We're squaring, right? Okay, so that's one thing, okay? Is it hard to square numbers? No, you know, sometimes that can be a little bit tricky, but with a calculator you can square a number, right? Okay, and then what's the other operation that we have here? Subtraction. Is it hard to do subtraction? No. Okay, yeah. There's no reason you shouldn't be able to carry out the subtraction. So, by default, that means, Ben, if we want to make the domain as large as possible, what would the domain be here? What numbers can you plug into the formula and carry out the arithmetic?
Maybe just any number.
Any number, that's right. Yeah, it'll just be any number. How can you say that now a little bit more formally for me? So the domain is any number. How can you say that a little bit more mathematically? All real numbers, right, okay. Yeah, there you go, okay. The domain is all real numbers for this function. Oh, that's my favorite domain, okay. So I really like it when the domain of my function is all real numbers, because that means I really don't have to think carefully so much when I'm using this function, because I can plug anything in to that function for the input, all right. So that's that makes the function much easier to work with. If the domain is not all real numbers, then sometimes you have to use the function. You have to use the function with a lot more care, okay? Because you want to be careful to not put functions in the domain. I'm sorry, not use functions as input that are not in the domain of the function, okay? All right, so here's our first example of finding domain from a formula. Notice we don't have a graph for this function, but we do have the formula, but we know now the domain's going to be all real numbers. Notice I didn't ask about the range, okay, because as I mentioned, range is a trickier issue, okay? For this function especially, it's trickier, all right? Okay, all right, let's stop there then. All right, we didn't quite make it through all of our examples, all right, but we got enough to get started on the 1.3 homework. If you're done with that, 1.3, part 1, I mean. The part 2 is very similar to the part 1, okay? But Taylor and I, when you get to questions that maybe you don't know, Taylor and I will explain them to you on the spot because they're easy to explain, okay? All right, well, I quit in pretty good time there, so we have